Hello. So it's new class for you, but the continuation for me. Sure. So as I promised, the next class is going to be the very important class. If you observe the PYQs, you will be getting a number of questions there from the first isomorphism theorem or Z curve phi isomorphic to image phi. Okay. Where phi is some homomorphism from G to G. So today's target is to reach here. Let's say they have defined how many possible homomorphisms are there from S3 to Z, or you can say how many possible homomorphisms are there from S3 to Z3, something like the questions like this. Previous year questions they asked, even the recent 21 also they asked the mains paper 2. So our target is to reach here only. Okay. How I have planned this lecture like this. Number first, we'll be doing homomorphisms. What is homomorphism? Definition, examples to visualize, properties of homomorphisms, right? Finding all possible homomorphisms between two groups, getting, and how isomorphism is just two steps further from homomorphism. Is that clear, guys? Is it visible to you all? Fine. When I say homomorphism, please be on the board. Let us define a map, a function from some group G star to the group, suppose that G dash to, okay. We say this mapping phi from a group G to Z dash is a homomorphism if it preserves the composition or the operation. What does it mean by the composition preserving? Means if I apply the composition between two elements of G, then it must be same as the composition applied between images of A and B under the map phi. This is called operation preservance. Is that clear? Means your map, your function preserves the operation. Applying that operation between two elements of the group or applying the operation between images of those two elements. Is that clear? I hope. For example, let's define a map phi such that let's say ZL to R star with respect to multiplication. Here what is the operation, dear? Multiplication of matrices. So this is my Z, this is my Z dash. What is star composition here? Multiplication of two matrices. What is composition? This is multiplication of two real numbers, or R star represents non-zero real numbers ka set. Is that fine to you all? Chalo. Where if I define a map phi from this set to this set defined by phi of some element gives me the determinant value of that element. Determinant is what? Tell me. Once in the lecture, no? Offline lecture, I asked this question. Not only once, sometimes I ask. People say, वो स्क्वायर मैट्रिक्स को ऐसा कर देंगे तो डिटर्मिनेंट हो जाएगा. Actually, determinant, see, determinant is a scalar value associated with some square matrix. इतनी लाइन की बात है. So this scalar value will be some real number. What I have restricted is कि I will take only those scalar values which are non-zero. So अभी मैं यहाँ पर if I enter something, some element here, I am getting some element of this. Okay. So whenever you define a map, you will be trying to have some structure like this. Any problem? No. Now I want to know whether this phi is operation preserving or not. So what we wish to have for operation preservance, dear? If I apply A into B, so this is multiplication of matrices, however you write. So A into B will be, because phi is defined like phi of something gives you determinant of that thing, and by the property of determinant, make it a point. Determinant of A into B is nothing but determinant of A into determinant of B. Is that clear? So can I write? Please make it a point. Don't cram actually. This determinant of A can be written as phi of A. Determinant of B can be written as phi of B. This is not a matrix. This is a scalar value. This is a non-zero real number. This is again a non-zero real number. Product of two non-zero real numbers again will be single non-zero real number. That means R star. That means RHS will be some element of R star. So what you shown here, कि phi of A multiplication matrix B is nothing but phi of A into phi of B. What it shows? Image of product of two element is same as product of images of those elements. This means phi preserves the operation. Is that fine? So yes, phi is a homomorphism from ZL to R to R star. Is that now clear? Everyone? Sure. In the same manner, we can discuss some other example also. Let's say, let's define a mapping from Z2 to Z6. Okay. Basically, we'll be taking two examples here. I guess that will be more clear. Fine. I want to check number of possible homomorphisms. Very favorite topic for any of the exam you are going to write. For clarification, you can check previous year questions of CSE as well as IFS. So that is my question. How many homomorphisms like this you can define? Suppose that phi 1 is a homomorphism from Z2 to Z6. Phi 2 is another homomorphism from Z2 to Z6. Defined by something, defined by some formula. So the question wants us to know how many such phi 1, phi 2, phi n you can define. What the question? So if you want to define a homomorphism, what is the definition, बच्चे? It must be operation preserving. Is that clear? Okay. So our target was Z2 to Z6. So Z2 is addition modulo 2. So elements will be like this, and for Z6 elements will be here addition modulo 2, here addition modulo 6. Don't repeat the mistake. These are not numbers, these are classes. Is that clear? Chalo. Now let's try to define a map phi1 such that Z2 to Z6 defined by the formula कि phi1 of some element x, phi1 of this element phi of x, it goes to 0x. Okay, number first. Let's define different formulas I am driving. After that we will check whether that is homomorphism or not. Let's define phi 2x as 1 into x. 1 into x कहने का मतलब ax operations you have. Z6 के पास ऑपरेशन क्या है? एडिशन मॉड्यूलो 6. You getting my point or not? So 1 into 6 कहने का मतलब 1 addition modulo 6, where x is coming from the set Z2. Similarly, I can try phi 3x as 2 plus x, and like this. Now our duty is to check whether this is a homomorphism or not. So for this to be homomorphism, what I need to show? It must be operation preserving. So let's take some element of this. For example, x plus y तो कर सकते हैं. For example, I have taken 0 here and here 1. So phi 1 of 0 plus 1. This will be phi 1 of 0 plus 1 is 1. By the formula, what will be phi 1 of 1 will be 0 addition modulo 6 plus 1. It will be nothing but 1 only. Is that clear? Now let's try to find what is happening with this thing. Phi 1 of 0 will be 0 plus this element, that means 0 only. So this will be 0. अभी आप समझ गए, इसका कहने का मतलब 0 plus 0 for this, and for this phi 1 of 1 0 into x. Why I'm saying into? Just like ax if you define, but this operation is of the group this, and this group has of the operation addition modulo 6. So what it will be here? 0 plus 1, and that is 1 only. So what you can say from this and this? Phi of 0 plus 1 is same as phi of 0 plus phi of 1. That means phi preserves the operation for these two elements. Is that clear? Arbitrarily element, let's say x belongs to Z2, y belongs to Z2. I want to know what is happening with this. This is an addition modulo 2. So this will be, we will be checking. So x plus y, it must be equal to this thing. So phi of something 0 into x plus y, operations you are getting, I have already defined. This will be 0x plus 0y. I will change the color also here. So this is 0 plus 0 y, and that's the same as 0x plus 0 y. So LHS equals RHS. That means for any arbitrary element, we have shown that phi of x addition modulo 2 is same as phi of x addition modulo 6 with phi of y. What it shows? Phi preserves the operation. So yes, this is a homomorphism. Getting? So one homomorphism you get from Z2 to Z6 as phi of x equals 0 into x. Is that clear? Let's check whether this works or not. Okay. Suppose that I want to check for phi of 1 plus 1. ये किसमें है? Addition modulo 2 में. So this will be phi of 1 plus 1, 2 in Z2. That means phi of 0. And phi of 0 by this formula, because phi 2 this you are taking. So by this formula, this will be 1 plus 0. Plus means addition modulo 6 में. That is 1 in Z6. Is that clear? Now I wish to have what is phi 1 addition modulo 6 plus phi 1, because for operation preservance we need to show that phi of this element gives phi of first element plus phi of other element, plus not ordinary plus. Okay, so phi of 1 by this formula will be 1 plus 1 phi of this formula will be 1 plus 1. What it is coming? 2 plus 4 in what? Z6. So phi of 1 plus 1, that is 2. So phi of 2 in Z2 मुझे मिला 1. Check it out here. So phi of 1 plus 1 is 1 in Z6, whereas phi 1 plus phi 1 is 4 in Z6. This implies what? That phi of 1 plus 1 is not equals to phi of 1 plus phi of 6, where this is in Z2 and this is in Z6. Is that clear now? So what you will say कि no, this is not a homomorphism from Z2 to Z6. In the same manner, you can construct like this. This is a very standard category where you are asked to find how many homomorphisms you can define in general from Zm to Zn. Getting? I will not give you the formula for this, because if I have given you the formula, this is my experience says you people will not be doing this exercise. The formula will be written on your assignment sheet also. So from there you can get. But here I am just giving you a task. Do this from Z3 to Z5, from Z5 to Z20. Define like this. You yourself will observe what's happening. What are those homomorphisms which are possible? Just a hint I am giving. Please write on your paper. If I am trying to define a homomorphism from Zm to Zn defined by, like formula for this homomorphism is phi of x as ax. We try to find possible orders of A in Zm. Please note it down. Please, I am saying. What I am saying? Try to find, for example, okay. Just I will change the color. Try to find, suppose that you want to know Z3 or here Z8, here Z12. You want to know if how many homomorphisms I can define from here. So for exam point, what you need to know, possible orders in Z8 इस वाले में. So how many possible orders? 1 divisor of 8 na, 2 4 8. You getting my point? Now you just check whether such order elements are also in Z12 or not. Means one order ka element Z12 mein will be there or not? Yes. Okay. So you can go to define a homomorphism like, because order of identity element is always 1. So first order element, this is the trivial homomorphism, or some people like this 0 into x, because I am not writing 0 here because usually you don't have the usual multiplication. You may have the matrices, you may have the composition of functions. So what I am writing, ki for order 1, if I want to define a homomorphism phi of x equals to ax, where order of a is 1, then the homomorphism will be always looking like phi of x equals to ex, and that is called trivial homomorphism. Getting? Means every element of this, what, whether it is ex or simple x or simple e, that is up to you. Okay, how you are trying to define that, because what will happen here, phi of any element, suppose that 1, so e1, that will give you 1 only, phi of 2, that will e2, that is 2 only, and like this. Is that clear? If your identity element is 0, so 0 into x, phi of 1 is 0, phi of 2 is 0, and all other elements. Is that clear? Also, 2 order element Z8 के पास तो है, then check whether this also has the element of order 2 or not. If yes, then phi of x equals to ax is a possible homomorphism, otherwise not. 4 order element, yes. So phi of x equals to ax is a possible homomorphism, where whatever I am talking about, elements of order of element a. 8 order ka element, not possible here. So what I will say, phi of x equals, here if I say 8x, not possible homomorphism. You got the point? So now it's a task for you guys, because again I will repeat that if you are not doing these exercises, everything will be blurred in your mind. Once, because for me in the earlier first time also when I saw the Galilean, then it was just like a curiosity for me. I never wanted to know the exact formula. Persons who are preparing for the higher mathematics like CSIR and GATE exam, they need to know all these informations by one shot. But if you are trying to write your UPSC CSE or IFOS, please dear, be in the habit of doing this exercise. Otherwise you will not be getting your marks, because you have subjective paper. You need to write all these things what I am telling you. Is that clear? Fine. So let's say if you want to define, if you want to know what are possible homomorphisms from Z4 to Z20, then you will write, let phi of x equals to ax is a homomorphism. Then you want to know what are the possibility of a, that means 0 into x, 1 into x, 2 into x, not only multiplying, I am saying 2 into means operation with this set or this group. So you want to know what of these formulas will follow the operation preservance and what are not. Is that clear? Is that fine? Fine. Chal. The formula, again I will say, formula will be given to you on the assignment part, formula will be given on the book also, but you need to do this exercise first. आगे बढ़े अभी, कोई दिक्कत? फॉर्मूला चाहिए? चलो लेक्चर के एंड में बता देंगे, है ना? Okay, so this was the process how you can define homomorphisms, how you can find possible number of homomorphisms. Now the next part is what is isomorphism. Just two steps further only. Phi such that G1 to G2 is an isomorphism if phi is operation preserving, number second, phi is 1-1 mapping or function, number third is phi is onto. What you need to have for an isomorphism? Additional two properties. Phi, if phi is only operation preserving, we say phi is homomorphism. So ultimately you can say a homomorphism which is 1-1 and onto also, that is called isomorphism. Is that clear to you all? Fine. So let's take an example for, suppose that R star with respect to usual multiplication to R star with respect to usual multiplication. Same groups you can take, no problem. Defined by phi of x as x cube. Is that? So number first, number second, I am defined one more mapping phi of x or phi of x as x square. Now I want to check what is a possible isomorphism and what are not. So if I talk about this, whether this is, सबसे पहले तो ऑपरेशन प्रिजर्वेंस होना चाहिए. So what you wish to have, phi of x into y, these are two elements. You want to know whether these are equal to phi of x into phi of y or not. This you wish to know. For this, since phi of x into y by the given definition will be xy whole cube. In the group theory, I told you earlier when I taught you the order of element, कि if x and y commutate, then you can write this thing. Otherwise, not. Because let's say xy square. So what you can write is xy into xy. Until unless these do not commutate, we cannot write it as, okay. So commutativity needed. Is that clear? Now it is coming as x square y square. So in general, if you want to write xy composition m times as x composition m times and y composition m times, it is possible only when x and y commute. Otherwise, you cannot write like this. Is it clear to you guys? Fine. So since x and y both are real numbers, they commute, and because of that I can write like this. This can be written like phi of x because x cube. This y cube can be written as phi of y ka image. Ultimately you have phi of x into y as phi of x into phi of y. This means phi is operation preserving. Any doubt? Then please tell me. Please raise your voice. No? Now I want to know whether phi is 1 1 or not. What phi? X cube. So if you are taking, suppose that phi of 1 ka image, that is 1 cube, that is 1 only. If you want to take phi of minus 1 ka image, that is minus 1 ka cube, that is minus 1, and so on. Also for 1 1 you can write, what is the process to show 1 1? You just take images for 2 elements and you check whether those elements are equal or not. So if I put x cube equals y cube, it will be same as x equals y. In that case, what we say, if images are same, then those elements are same. So it is 1 1. Now, is there any real number which cannot be cube root of something? Because onto is what? There is no element here which cannot be. If I say minus 1, so minus 1 is the image of minus 1 here, because minus 1 ka cube will give me 1. Ultimately, is there some element, it is question for you, in R star which cannot be cube of some real number? If no, means each element of this R star is image of at least one element of this R star. So we say कि this mapping is onto. What mapping? X cube wala. And for that, for mathematical, what you do? For onto, phi of x you put as y. That means x cube as y. That means x is y raised to the power 1 by 3 and so on. So x will be nothing but phi inverse of phi. So that means if you take any element in R star and it is image of some element in R star of the domain wala. So what it is saying is that yes, phi is 1 1, phi is onto, phi is operation preserving. But don't be in a hurry. If you have any crux here, then let me know in the comment box. Minus 1 raised to the power 3 by 2 is what? Whether it is going to be a complex number or it is simply a real number, you have to tell me in the comment section. Is that fine? Sure. Let's move now. So I hope isomorphism is clear to you guys now. We have two very standard examples in isomorphism. And that you call theorem also. Number first, you can, like exam point, you can say PYQs, whatever you wish to have, you can write. Yes, they ask in the recent exams also. Every finite order cyclic group is isomorphic to Zn. Please make it a point. Every cyclic group of order n is isomorphic to Zn. Is that clear to you all? Fine. Let's say, so proof is very simple. Let Z be a group of order, and please do remember this statement also, very important. I'm saying application of this theorem also we do, or directly questions are asked in the CSE exam. Let G be a group of order n. If G be a group of order n, then if I do composition n times of any element, this you can represent at a raised to the power n, but that doesn't mean raised to the power. This means a composition n times. It will give you identity, or ultimately a composition order of G times is identity element. This exercise you have done in the order of element wala. Okay, fine. So what I have taken, let G be a cyclic group of order n, then a raised to the power order of n equals to identity, means a raised to the power n is identity always. Now let's define a map phi from G to Zn by phi of x. Since G is a cyclic group, so it must have a generator. Any doubt here? Let A is generator of G, then every element of G, that will be some composition times, sometimes composition of A. You got the point? If G be a cyclic group, it must have at least one generator, means each element of capital G of the group will be generated by that element A. Generated means by doing multiple compositions of that element, we get each element of the group. So what I'm gonna do is, if I take any element of this G of capital G, I'm defining the formula like M. You're getting my point or not? How? You can also write please check it out how I defined the formula. Many students, even I myself, suffered in my graduation that how these mappings are defined. How easily a professor comes to know ki this I have to define like this. So for this, please note it down on your paper. This mapping or this formula will be defined like the intuition or the hint given from your groups only. So I have G cyclic. Ultimately, my mind is always framed कि if G is cyclic, then its element will be of powers of some element, and that element is generator of that group. And these powers, if G is a group of order n, then a square, a cube, a n minus 1, because a raised to power n will give you identity only. Be here please. If G is generated by a, then it will be a square, a cube, a raised to the power n minus 1, और a raised to power n जैसे ही करेंगे, that will give you identity element. Is that clear or not? So what it indicates कि if you have some cyclic group, then you will have n powers like this, where each element will be represented. It indicates me to define phi like powers of generator, or you can say number of times composed. This A is being composed. You got the formula? Similarly, whatever mapping you are trying to define, you will use the identity of your groups. So this is how intuition comes. If you are still not clear, please go back to the statement and listen it again, see it again. So let's say I have this. If I have a formula like this, so what ultimately I am going to do here? Phi of a as 1, phi of a square as 2, phi of a raised to power n minus 1 as n minus 1, and phi of a composition n times will give me identity. N means e, e means the power 0, or you whatever you can say 0. You getting my point? Why I have written this n? Just I am coming on your point. If you want to write, you can write n also here, but I will take, because sorry, phi of some element will be element of Zn. So this phi of a is 1 in, ये किसमें है? Zn में, 2 in Zn, n minus 1 in Zn, n in Zn, and that is nothing but 0. 5 in modulo 5, 0. You are getting my point? I think I am done. If you are defining some mapping G to Zn like phi of a composition m times as m, this m will be in dear Zn. Okay? Zn, because your codomain is Zn. What I have shown, this is, see from here, do any two element have the same image? No. A 1 1, a square 2, so that means phi is 1 1. Clear? Any element of Zn, Zn के elements are 0 1 2 n minus 1. So each element is image of some element of capital G or not. So phi is on 2 also. Is that clear? Any problem? Rest, the thing is to show phi is operation preserving or not. So see from here, if I want to write phi of a m and a p, let's say, so this will be defined as phi of a raised to the power m plus p, or m plus p times composition. How I have defined my mapping? M plus p in Zn. This m again I can write phi of a, this p again I can write phi of a raised to power m and a composition p times. Means phi preserves the operation. So what it indicates? What I have shown you guys. We are able to define a mapping from Z to Zn such that phi is operation preserving, phi is 1 1, phi is on 2. Therefore, phi is a homomorphism from Z to Zn. Now you can take any order. Let's say G be a cyclic group of order 5. Then G will be isomorphic to Z5. Let G be a order of cyclic, please highlight, cyclic I am saying. Let G be a cyclic group of order 101. Then G will be isomorphic to 101. So on. So please do remember this statement, कि every cyclic group of finite order n is isomorphic to Zn. Is that clear? Now, although I could tell that why isomorphism needed practically. Should I tell? Yes. See, if I am isomorphic to some person B, to some person C, to some person D, okay? Or you can say some 10 persons are isomorphic to me. So in mathematically, we all 11 will carry the same properties. Please make it a point. Properties. I'm not saying कि हम लोगों का मतलब we will be all identical. No. I'm saying properties. So whether you read about all those 10% separately or you read my properties only, both will be same. Both will work to conclude something. Is isomorphism. Means you may have 1000 groups of finite order, let's say 10. You may have 2000 cyclic groups of order 10. So whether you will read all those 2000 groups or you read only about Z10, conclusions will be same. So this is what isomorphism does. So mathematically isomorphism मेरे लिए calculation है, but in actual life isomorphism plays a very important role. Means you have some identical object and you study about this, conclude something enormous or infinite number of other articles. Getting isomorphism? Chalo. Should I move? In the same manner, for isomorphism, there is a Calais theorem. Its proof is expected in your UPSC, CSE, as well as IFS. What it says, please do remember the statement, the previous one and this one, very important. What it says is, every group of finite order n is isomorphic to some group, to some permutation group of that order n. Please read it again. This statement. What it says, earlier statement was cyclic groups. Every cyclic group of order n is isomorphic to Zn. Whereas this statement does not include the cyclic property. This says in general, if you take any, but it is talking about finite. Many people miss such keywords and they do blunders actually. So what it says here, a group of finite order n is isomorphic to some permutation group. What is permutation? Collection of all 1, 1 on 2 functions with the operation as composition of functions. Is that clear? Fine. So again, the story. Please make it a point here. Finding that formula, writing that formula is the task here. Once you are able to write that formula, the life is easy. And those there are not 1000 examples like this. What is the trick? Where the intuition come from? Tell me. The intuition will be coming from the identity not identity element, recognition, pehchan, है ना? The format of that group. It indicates how you will write that formula. Fine, it is? Okay. Let's try. Let's G be a group of order n with elements G1, G2, G3, Gn. Order of G is n. Means any element को अगर n times compose करेंगे, you will be getting identity element of G. E will be some element among the Zi. E just the representation of identity element of this group. Is that clear? Fine. Now, we want to define a map from G to some G dash, and G dash will be nothing but group of permutations. Okay, please note it out. Now drop your pen, please listen with the patience. First I will make you visualize. This is also one trick I have developed, because in understanding theorems ka proof I'll be always having the trouble. Then when the visualization part over which I worked, abhi dekhna, just 5 minutes you just give me. Let us have G as a group 1 omega omega square. Cube roots of unity. Omega cube will be 1. I want to define G to G dash, and how my G dash will be looking, that I want to make clear here. Okay? Suppose that try to find all possible 1 on 2 functions from 1 omega omega square to 1 omega omega square. Let's try. Let's say 1 omega omega square. 1 ka image 1, omega ka omega omega square. This is my function 1. Let's define another 1 on 2 function where 1 ka image omega. Please be on the board. Omega ka square and omega square ka image is 1. I have defined another function knowingly. Please don't worry. F3 I defined like, these are the domain part and here is the range part. So how I defined F3 as 1 ka image omega square, omega ka image 1 and omega square ka image is omega. Getting? Now I take G dash as the collection of these 3 functions F1, F2, F3. Is that clear? Any doubt? No. So what you have dear? Now your phi is from a group 1 omega omega square to F1, F2, F3. Now you want to define this phi of 1. What will be this phi of 1? And this is the task for you guys. If you are able to define this formula, then ultimately you just need to cross check whether it is operation preserving 1 1 or 1 2 or not. Okay, although I may write this formula, but I'm trying consistently to insist you to think how the things are coming. Otherwise everything is written on the book from the childhood only. Getting? So how these functions I have defined? What I did, I just defined a map from 1 omega omega square to 1 omega omega square, like f of a map where I did is f of a as 1a, okay, f2a that I can write f omega a and I defined this as omega a, f3a that I can say f omega square a and I defined like omega square into a. Please check it out. F1 of 1 f1 of omega f1 of omega square is omega square. Fine. Check it out. F2 of 1 will be omega, because how I defined the map? Omega into a. f1 f2 of omega will be omega into omega, that is omega square. f2 of omega square will be omega into omega square, that will be omega cube, and omega cube is 1. Getting? Is that clear? नहीं clear? एक और देखते हैं. I have defined a function f3 such that I represent it as f omega square of a, and it is defined as omega square into a. What does it mean, dear? f3 of 1 will be omega square into 1. So omega square into 1, omega square. f3 of omega, omega square into omega, omega cube is 1. f3 of omega square into omega square, omega power 4, and omega power 4 can be written as omega cube into omega cube is 1, so this is omega. So these were not random functions. Ready? Intensely we have defined कि f1 of 1 goes to 1 into a, f2 as omega into a, f3 as omega square into a. What I am going to do with these functions? I am constructing another group which is, this is my z dash, where elements are coming from these f1, f2, f3, or you can write those as f1, f omega square. So g dash is what? Any doubt here? Anything? No? Chalo. What I'm gonna do is, now I'm trying to find an isomorphism. For that, I will define a formula from G to Z dash. And how I have defined the formula as if phi of 1 as f1, phi of omega as f omega, and phi of omega square as f omega square. Make it a point here. Now our task, now our job is to check whether this phi is operation preserving 1 1 on 2. 1 1 on 2, it is looking to you. It is very normal because every element has single image, unique image, and no element of this is remaining, and means this codomain is equal to range also. So this is 1 2. Why I have taken this example? Because I myself told you that theorems are not proved by examples, but these examples show me how I should proceed in general. Getting? So in general, if I want to prove of order n, what I will be doing is I will be defining a formula as phi of z1, that will be some function of fz1, phi of z2, that will be 1 1 on 2 function as fz2. In the same manner, phi of zn will be a function f of zn. And how this f of z1 will be defined as, because this is again a function, na? So let's say I want to write fg1 of 1, this will be nothing but z1 into 1. If I want to write fz1 of z1 here, fz1, matlab this function of z2 will be nothing but z1 into z2, and so on. Similarly, I can talk like this, I can talk for this, and this is the same story what I did with this. Check it out. Is that clear? Any doubt? No? Aram se you can look. With this example, I send you here, and that is why I'm much in love with the algebra, because I started visualizing the things. Now I think this proof will be easy for you. You just need to show whether phi is operation preserving, phi is 1 1 or 1 2 not. 1 1 1 2 तो यहीं से दिख जाएगा, है ना? Operation preservance के लिए again that composition of functions you can associate with that. Is that clear? Any doubt? So there is a task for you. Write phi such that G to G dash, where my G is 1 minus 1 iota minus iota. You just tell me what is G dash. That is your task. Okay, let me know in the comment box also. Should I move? So what we have studied? Homomorphism, operation preserving only. How to find possible homomorphisms. Examples के साथ we have visualized that. After that, I have taught you isomorphism. Examples I have given you. In the same manner, you can do lot of examples from the assignment which are given to you in the PDF form. Now, what I wish to have the first isomorphism theorem. After that, we will be again landing up on how to find possible homomorphisms. That question, this 21 also they have asked in CSE. Chal. So first isomorphism theorem, that is, if phi such that G to G dash be a homomorphism, then G kernel of phi is isomorphic to image under phi. परेशान नहीं होंगे, अभी बता रहा हूं मैं आपको. Don't be panic. This is my way of understanding the things. Where the need originates, I will teach that concept there. So here I have something new, ker phi, that is kernel of phi. I am going to teach you what is kernel of phi, whether it is a group, whether it is a normal subgroup, because factor group you can only define when ker phi is a normal subgroup of G. Okay, so yes, this is our exam point. Please do remember this theorem, very much important for you guys. Okay, so now just I am going to define what is ker phi. That is called kernel of a homomorphism. What you do, let phi is a homomorphism from G to G dash. Then kernel of phi is the collection of all those elements of this group or domain part which are mapped to identity element of G dash by the map phi. Please do remember definition and don't miss the words. First, phi should be a homomorphism, then only we are able to define kernel of phi. For simple function, we don't talk about actually. Is that clear? So kernel phi is what, dear? Collection of all those elements of the domain which are mapped to identity element of codomain by the mapping phi. Fine? Okay. Here, since if phi is a homomorphism, then you may have n number of properties. That is again a topic, that is the interconnection actually. Properties, phi of identity goes to identity only. Phi of G composition M times is nothing but phi of Z ka composition m times if phi is a homomorphism. Getting? Properties like order of G and order of phi of Z, the relation between these. So in the Galilean also, they have given these 4 to 5 properties as in the Coastal theory I have stated you. Please note down these properties. Do remember these properties. What? Do remember these properties. Okay? Back to. So since if phi is a homomorphism, then identity element of G will be always in curve phi. So curve phi is always non-empty. Any doubt? So that is the first point, ki curve phi is non-empty always. Next is whether curve phi is a subgroup of G, and the next target is whether curve phi is normal subgroup of G or not. Okay. For subgroup, what you do dear? For A belongs to curve phi and B belongs to curve phi, we need to show AB inverse also belongs to curve phi. यही तो target है. Then only we can say कि this holds well. Is that clear? Fine. Since A belongs to curve phi, this means phi of A goes to identity element. B belongs to curve phi means phi of B goes to identity element of G dash. What I wish to have AB inverse. If I wanted to show AB inverse is also in kernel phi, then what we need to show here? Phi of AB inverse must be identity. Is that clear? Sure. Since phi of AB inverse, it is equal to phi of A composition phi of B inverse. Why? Since phi is a homomorphism, इसलिए operation preserving. If phi is not homomorphism, we cannot move from this step to this step. So what is phi of A? E dash. What is phi of B inverse? Is phi of B inverse. Please, ये जो property वाला part आप कर रहे होंगे, there also you will note phi of inverse of some element is same as inverse of phi of that element. Note it down. Phi of A inverse is same as phi of A ka inverse. Getting? So that I used here. Ultimately, it comes out to be E dash composition E dash. That means same as E dash. So what you've shown, this implies AB inverse belongs to kernel phi. And we are done or not? Tell me. Sufficient, necessary and sufficient condition for H to be a subgroup. If A and B in H, you need to show AB inverse in H, then H will be subgroup. So yes, this happened. Now you want to check the kernel. Once it is subgroup, then now we are moving to kernel, normal subgroup of G or not, because if curve phi is not normal subgroup of G, then we cannot define quotient group. Okay, let's check. For normal subgroup, what we do? Actually, why I am writing on the same board? Because when I was as a student only, I was in the habit of taking screenshots. So many things, multiple things are on the same screen. It works good for me. It is up to you. Let's say I will change the color. Changing the color feels good, because वहाँ पर दिख जाता है what I am trying to do is. Okay, fine. So अभी what I am going to do? This वाला part. Let G belongs to capital G. Okay. And small k belongs to kernel phi. I want to know what is GKZ inverse. If GKZ inverse in kernel phi, we are done. So phi of GKG inverse. Since phi is operation preserving, so phi of G, phi of K, phi of G inverse. What is phi of G inverse? That is phi of G, and phi of K is what? E dash. That is 1 upon phi of G, because phi of G ka inverse. Is it clear? So what will happen here? This is going to be cancelled out from this, and this is E dash. What it shows? Image of GKZ inverse is also identity element. So GKZ inverse will go inside the kernel phi. Is that clear or not? कुछ लोग सोच रहे हैं कि सर अलग लिख दीजिए, चलो अलग ही लिख देते हैं. G आपका G में है, K kernel phi में है, लिखने में क्या दिक्कत है? Easy only. So if K is in kernel phi, that means phi of K gives E dash. Now I wish to have कि GKZ inverse kernel phi में है या नहीं. So for that, चूंकि phi is homomorphism, so what it will be? Operation preserving. By the property of homomorphism, it will be phi of G inverse. Is that clear? So phi of Z into, this is identity only, and this is phi of G inverse. This is phi of Z into composition identity is phi of Z, and composition phi of G ka inverse. So A into A composition A inverse gives me identity. Phi Z is the element of Z dash. So what it shows here? Phi of GKZ inverse is E dash. This implies GKZ inverse belongs to kernel phi. And what is the definition of normal subgroup? This implies kernel phi is normal subgroup of G. So once kernel phi is the normal subgroup of Z, now we are free or able to define a quotient group G ker phi. What will be? This will be collection of cosets of ker phi in G. That clear or not? Everyone? Fine. So what was our target? If phi is a homomorphism from G to Z dash, then G ker phi is isomorphic to image phi. Now kernel phi, you guys know. What is image phi? Range of phi, collection of all those elements which are images of at least one element of this G. So what we were doing till now, when I have started, every finite order group is isomorphic, every finite order cyclic group is isomorphic to Zn. I told you how to define that formula. Calais theorem. Every finite order group of order n is isomorphic to some permutation group. How that formula is defined, that I gave you. Now, this is the theorem we have. So what is the pehchan? What is the identity of this? This is collection of cosets. Okay, and this is image of phi, means if this set contains G1 dash, G2 dash like this, then G1 dash will be image of some G1 under the map phi. हो गया? और कुछ define करूँ क्या? Now I'm gonna define a mapping from G ker phi to image phi. G ker phi, this is collection of cosets of ker phi in G. So this set can I write like you will be having some G1 cur phi, G2 cur phi, and so on. This is not an element, this is a set. This is a set. Getting? So what I'm gonna do is I'm defining a map from this to this. How? Defined by formula. Please be on the board. That is the crucial thing for you guys. F of, let's say I have taken an element Gi cur phi I. You're getting? Phi. And I want to know what is the image of this element under the map. So this image will be some element of image phi or not? Image phi के elements are looking like this, G1 dash, G2 dash and so on. So if I define Gi dash, please notice this formula. F of Gi kernel phi, Gi in suffix means cur phi I coset, left coset by Gi. So how I am defining some other function f like this. Now your task is whether it is 1 1, whether it is operation preserving or 1 to 1 not. Take two elements here and go there. Operation preservance. See guys, although these all proofs are written on the book, but as a student I suffered a lot there to understand. That is why I am much concerned about those things which are necessary to make these concepts clear. Not doing all that bookish stuff, writing okay, this. No, I'm just focusing. Why I'm stopping myself again and again at such concepts? Because if these things are clear now, you will be very much comfortable in algebra. So if you want to prove this thing, you need to have first phi. So phi is the function, phi is the homomorphism from G to G dash. After that, you need to define or you need to show that G cur phi is isomorphic to. So please, now I am just to conclude this thing. To show, please have patience and listen it carefully. To show G1 is isomorphic to G2, we need to find, please focus, this is experience, this is coming from experience. We need to find a map from G1 to G2 such that F is operation preserving 1 1 and on 2. So whenever somebody says so that this group is isomorphic to that group, what you need to have, you need to define a formula which is operation preserving 1 1 and on 2. You need to define a formula. How you will define? This got gifted? No, the intuition will be coming from the set ka pehchan, set ka identity. Getting how I used that thing? So in case here in the first isomorphism theorem, first you have an homomorphism, then you are trying to find that F with the help of that homomorphism so that our composition or our calculation becomes easy to understand. I hope this is well clear for you guys. This first isomorphism theorem is very much important. I'm just giving you 2 minutes here. You need to think over these things, and after that we will be deciding how we will be using this isomorphism theorem. Ready? Do it. They asked the question over this, but merely the first and last focus, foremost focus was you are able to think like this or not. Okay, just think over it. I'll just take the water. 2 minutes only. Don't go there. Just pause your screen. I'll be there. Abhishek, bottle. Wait. Okay, so let's start. How I will be using that isomorphism, first isomorphism theorem. Most important part. Let's say if someone says find possible homomorphisms from a group G, C1 to Z2. Okay. For example, if somebody says how many homomorphisms are possible from Z from S3 to Z3, like this, S3 to Z5 or whatever you wish to, Sn to Zn, simple. Again, the concept I could teach you, like how to write all those, what are the formulas for that, but I didn't go in that because I realized first we need to be clear in the algebra, otherwise everything looking like यार ancient and history के like ना, पढ़ जा रहे हैं बस पढ़ रहे हैं ना. So this is my task. Okay dear. So what my first isomorphism theorem says, if phi is a homomorphism from Z3, S3 to Z3, then S3 ker phi isomorphic to image phi. Okay. Now, if I wish to know what are those images possible, let's say phi 1 S3 to Z3 is a homomorphism, then S3 to kernel phi 1 will be isomorphic to image phi 1, another phi 2, then this S3 kernel phi 2 isomorphic to image phi 2. So I wish to know what are those possible phi 1, phi 2, phi 3 and so on. That means I wish to define some formula which is gonna be a homomorphism, which is gonna be operation preserving. Then I will say ki, okay, that phi works for this, that phi 2 works for this, phi 3 works for this, like that. Is that clear? Now, one more concept, although I could teach it just after the coset theory, but I didn't teach there because I had an intention behind that. Order of G divided by H naught, order of the coset group GH is nothing but order of G upon order of H, or you can say the factor group GH contains number of elements as order G divided by order H. This you can say collection of a number of elements in GH. Number of elements in the quotient group GH will be nothing but number of all distinct cosets of H in G. Since H is normal subgroup, then only we are able to write the quotient group. So left cosets will be same as right coset for each element. That means if you want to know what is, it is also represented as index of H in G. Please remember, index of H in G, this is nothing but order of G divided by order of H. Provided that these are well defined, means G is finite order group. Is there any doubt? So there may have, for example, if you want to know what is order of S3 A3? This will be nothing but order of S3, order of A3. That will be nothing but 3 factorial and 3 factorial divided by 2, that is 2 only. So how many cosets of A3 and S3 are? 2. That we also watched it or saw it earlier. For example, order of Sn An. This is nothing but n factorial divided by n factorial by 2, that is 2 only. That means number of cosets of alternating group An is as in Sn are always 2. So एक कोसेट तो An खुद हो गया और एक कोसेट उसका कोई दूसरा होगा. That means the left coset of An in Sn will be same as right coset of An in Sn, because if this doesn't happen, then this will have this element, 3 elements. But what you have shown, this has only 2 elements. So one way to show An is normal in Sn, that is also here finding the index. So people also use that theorem ki if index of some subgroup in their group is 2, then that group will be normal subgroup of that group. So why? Because there are only 2 cosets. One is the set itself, वो जो subgroup है, दूसरा वाला एक और coset है. So if either you write left coset or right coset, if left and right becomes different, that means this will have more than 2 cosets. But index is 2, so you must have 2 cosets. That means that subgroup will be normal subgroup. So there may be n number of ways there. Clear? Okay. So why I have told you here one concept, this is, I could take 1 hour lecture for this also. But this course is designed like to help you guys, to mentor you guys. And people who know me from the Quora, they know I'm much interested in teaching. I'm more interested in mentoring, in finding out and bringing out those capabilities out of you guys. That clear? So why I have told this thing here? Okay, let's move to this thing only. When I will be using first isomorphism theorem, there I will be using this thing. So let's say I want to know whether S3 to Z3 phi1 is a homomorphism or not. Then how we proceed? Okay, let this be a homomorphism. Okay, if this be a homomorphism, then by first isomorphism theorem, S3 kernel of phi1 must be isomorphic to image phi1. Is that clear? If this is a homomorphism, then this must hold. If this is a homomorphism and this does not hold, we will say this is not possible. You are making me fool. So this is the concept here. To check step 1. Step 2. Please have patience and see it. Check possibilities for kernel phi. So kernel phi, number 1 case, let's say it is trivial. It is identity element only. Second, let's say kernel phi is identity के अलावा something. Let's say kernel phi is like this. So how we use this first isomorphism? We check possibilities of kernel phi. What we do? We check possibilities of kernel phi. Please be here. Let's say this is the possibility. If this is the possibility, so order of कर phi कितना होगा बच्चे यहाँ पर? 1, because 1 element here. Now step third, order of S3 curve phi. What will be? Just I have told you, order of S3 upon order of curve phi. Order of S3 is 3 factorial. Order of curve phi, what you are checking is ki whether it is 1 or not. So this is going to be 6. Means order of S3 curve phi is 6. So by first isomorphism theorem, S3 curve phi is isomorphic to image phi. Please have patience. Order of S3 curve phi is 6. That means this image phi should be also of order 6. Otherwise, because S3 curve phi isomorphic to something, and order of this thing is different from S3 curve phi. So whether it may be isomorphic or not. You getting my point? Possibility, if this is also of order 6, or this image phi 1 is coming from this group, let's say this is G dash, this S3 curve phi is isomorphic to image phi, then image phi ka order is going to be possible from this thing only. Now if this has the order 6, then image phi may have, or possible order is 6, but image phi is a subset of this set Z3, and order of Z3 is 3 only in modulo 3. That means this is not possible. This is not possible means kernel phi is trivial, is not possible. In the same fashion, you have taken like this na. You can say second possibility. Let if order of kernel phi is 2. So order of S3 kernel phi, what it will be, dear? Order of S3 curve phi will be 3 factorial divided by 2, that is 3 only. That means image of phi under this phi will be of 3 order, and 3 order ka possibility here or not? Yes. So yes, it is possible. That means you can define a homomorphism phi such that kernel of that phi is of order 2. Similarly, you can talk for let if order of kernel phi is 3. Getting my point? If kernel of or this 3, चलो लिख ही देते हैं. एक तो होमोमॉर्फिज्म ये मिल गया, दूसरा वाला let if order of curve phi is 3, then order of S3 curve phi will be 3 factorial divided by 3, that is 2 only, and 2 order in S3 possible. Image phi is a subgroup of this, no? Image phi is a subgroup of this G dash 0 S3. Then order of image phi must divide this Z3 by Lagrange theorem. Is that clear or not? So 2 divides 3. No. That means order of S3 curve phi is 2. Order of curve phi 3, not possible. That means you cannot define a homomorphism with kernel phi ka order as 3. You getting my point? Okay. And since curve phi is a subgroup of this, image phi is a subgroup of this G dash. So order of curve phi's are possible क्या होगा? So order of curve phi must divide the domain wala group, and order of image phi must divide the codomain wala group. So domain wala group is S3. So possible orders of subgroup कितना होगा? 1. क्योंकि इसका order कितना हो गया? Order of S3 is 6. So 1, 2, 3, 6. Getting? Any problem? So let next possibility is कि let if एक ऐसा होमोमॉर्फिज्म डिफाइन करते हैं वी, लेट अस डिफाइन अ होमोमॉर्फिज्म सच दैट ऑर्डर ऑफ कर्नल फाई इज 6. ऑर्डर ऑफ कर्नल फाई 6 कहने का मतलब ऑर्डर ऑफ S3 कर फाई विल बी 3 फैक्टोरियल डिवाइडेड बाय 6, दैट इज 1 ओनली. एंड वन ऑर्डर का सब ग्रुप Z3, yes possible, Z3 will have one order का सब ग्रुप. So yes, this is a possible homomorphism. Is that clear or not? Huh? So just in one line, how you will be checking possible homomorphisms. A phi or a mapping or a homomorphism is possible if order of G कर phi, that means order of image phi जो है, that is possible in the codomain वाला group or not. And how to check the possibilities? Let's say you have taken here S4. So kernel phi is a subgroup of S4. Acha, this is also a homework for you. Kernel phi is a subgroup of domain wala group. Image phi is a subgroup of this codomain wala group. Okay. So that's an exercise for you. So how we will be checking, dear? Just up to one line ka kaam only. Kernel phi ke possible orders you just write and use first isomorphism theorem. How to use that I have told you here. And if order of G कर phi is possible order of this group, then that homomorphism is possible. Otherwise, nahi. Is that clear? So this is the beauty of homomorphism, isomorphism, index of group and all. I hope this lecture helped you. If anything is not clear, please let me know in the comment box, so that the problem lecture or the exercise lecture, in that lecture I will define, I will make it clear of all your problems. Sorry, lecture थोड़ा सा ठीक है, आपका तो सेकंड है पर मेरा कंटिन्यूशन में चल रहा है. Anyways, so this is the beauty of group theory. Let's meet on the next class. And in the next class, we will be discussing the very important topic as class equation. In that class, we will define also how a group of order p square prime p. Okay. What you can say about group of order p cube, if it is abelian, if it is non-abelian, how you write the class equation for S3 or any group. So all that will be dealt in the next lecture, and that is gonna be very interesting class. So stay tuned. We'll meet in the next lecture. Good luck.